We've got 66 with us. I think we're about 4 minutes in, so let's get started. We do have a couple people that may straggle in and they can get caught up. But basically, I wanted to start off by just explaining kind of who we are. So Genome is sort of two of Canada's largest extraction equipment manufacturers, Evolved Extraction being one, Yellowstone Extraction being the other, and we've sort of joined forces to create Genome. And Genome kind of sits in a unique space. We're founded by engineers and former processors. We also do our own in-house fabrication of a lot of this componentry, and looking to solve your guys' bottlenecks and making sure you're dominating your market. You can flip to the next slide, Linden. So what do we do? So basically what we do is we fabricate equipment, and a lot of this equipment is, we can either build out full systems, but a lot of the work that we're actually doing is integrating new components or modules to kind of tackle key bottlenecks, especially in hydrocarbon extraction. And so, we can add existing components to your guys' existing hydrocarbon systems, maybe like an additional solvent tank or, an additional plate exchanger or something like that, or some more complex modules that we've developed, like a regenerator or our dosing pump package, which Linden's going to dive into of, what bottlenecks those solve and how that really kind of maximizes your potential throughput. So in short, we're able to, create individual things that can be integrated into your system, which is kind of the title of this webinar. But we also do full build outs as well. Go to the next slide. And so how this all came about, funnily enough, is Murri put out a post. I think this is in 2018, or at least around then. And the question that was posed to her Instagram audience was basically, of all these different turnkey systems, who's modifying their system after they get it? And sort of to no surprise to us, 80+% of the respondents said, yeah, I'm modifying this thing as soon as it gets out of the box. And that's not really a surprise to us. Obviously you guys know that you've got specific, market demands that you're trying to meet. You've got different input biomass qualities, different SOPs. You're tinkering around and trying to do things on the fly. And so modifying the system isn't what came to a surprise. But what did come to a surprise is, why aren't these manufacturers making these modifications and built to design to tackle those things, specifically what you need? So tailoring the solution for what you need. And hence, then Genome was born to really try to tackle those things. And the short answer to why most of these manufacturers don't do this is because it's difficult, right? It's a lot easier to just make a system and just say, this is the system, and if you want to tweak it, tweak it. Whereas we kind of take a different approach where we're trying to understand what you're trying to accomplish and then systematically doing that in a safe and compliant way. You can flip the slide. So yeah. Part of the way that we do that, obviously, we do our in-house fabrication. We've got a team of engineers, chemists, and we're processors ourselves. So we understand the process in detail. But one of the key tools that really sets us apart is our Genome Technology Center. And so what makes this kind of unique is that we're actually in the lab doing and making these tweaks on the fly, right beside our fabrication. And so this allows us to basically provide three pillars of what we call our unique value proposition. And that is, the first one is continual product and process development. So Linden and his team are continually in the booth. They're doing these processes, they're optimizing them, they're making them more streamlined. They're saying, man, we're having a lot of problem here. Okay, we need something for that. And then they're doing it on the fly. And then we're sharing that information and those learnings with our clients and with the community. The other piece of this is we're also able to do custom feasibility testing and product demos. So some of you may have actually come to this facility and had either a private demo or are conducting some feasibility testing. And we can run a whole bunch of different tests. An example of this would be, we're currently running CO2 crude extract into our controlled crystallization method. But we do a whole bunch of different feasibility testings, and we can also do mass balance calculations and really dial in the equipment and the process to your specific requirements. And then lastly, it allows us to offer hands-on seminars and education. We feel that education is, really lacking in the industry. And so this really helps bring a whole bunch of new ideas, not only from us to the attendees of these seminars, but also attendees bringing new problems and challenges and ways that they solve these challenges to us. And it's, a lot of networking and sharing of ideas and then acting on those ideas in a kind of orchestrated way. And so this technology center really gives us a leg up on being able to really deliver, groundbreaking products in a really quick manner, and being able to roll it out across to all of our clients. You can flip the slide. So the best part, the webinar hosts. So first of all, we've got Linden, and Linden is the CEO of Yellowstone Extraction. He's also the CTO of Genome Technologies. And so his focus is optimizing solvent recovery times and, of course, developing the controlled crash technology and method. We actually have another seminar coming up at the end of August. If you haven't, webinar at the end of August. If you haven't signed up for or want more info, just type it into the questions. It's actually on crystallization. Can't remember the title of it, but it reviews our crystallization method and crystallization in general. But Linden's been instrumental in developing the genome. He's the mastermind behind Genome and the controlled crash technology itself. Linden, you want to say a few words?
Yeah, I think that sums it up pretty well. We started out with in the ethanol space doing falling film evaporators, and then really our passion is in hydrocarbon extraction. We started out processing and then discovered crystallization, quick crystallization, while we were trying to do some dewaxes, and kind of the rest is history. We've built up to be an ASME shop, doing installs all over, kind of implementing the technology and solving people's problems. It's a lot of fun.
Awesome. Thanks, Linden. And then joining Linden is Murri, obviously a hydrocarbon giant in her own right. Most of you probably already know her. She's a staunch advocate for hydrocarbon extraction safety and optimization. She provides consulting services across North America and emerging markets. You can follow her insights and updates on Instagram under her handle Murri. And she's also one of the instructors at one of our seminars, the Controlled Crash Seminar. The next one is scheduled for September 14th and 15th. If you'd like more info, shoot a note in the questions section, and we'll be sure to get that over to you. Murphy, can you tell us a little more about yourself?
Oh man, I'd rather tell you more about how to make hash, but I've been working in this space since I was 21. So, before I learned how to learn things, I started, I'm one of those people with the rare experience where I never learned to open blast. I started with the Temesium. I converted a CO2 extractor. And then a few years later, certified systems were on the market. I, got my start in Colorado, so we had the ETS systems, right away, early. And I think my first serial number from them was 19, and the next one was 23. So I was, early in with their single system, and I've been extracting at pretty much every scale almost since. I've done most other methods of extraction. The only one I don't recommend is CO2. And, outside of that, I take a lot of pride in triggering the discussion that led to building customizable equipment, because it's the gap in the market. As a consultant, and having worked with a company like ETS that, is on the top end and early end of getting things certified and standardized, and then also working myself, being one of them, with people who are building and modifying closed loops, the gap between a standardized and certified system and a customized unit has, gone miles in some places. And as a consultant, it's a really difficult position to be in, to tell someone that they're not allowed to do something that they're capable of. But if you don't, then what ends up happening is people end up trying to do something that they're not capable of, that isn't safe. And so again, we have these two goals miles apart that could meet in the middle. And, I love being in a position where I can recommend to someone, in any other normal manufacturing process, you'd be able to say, here's what I have and here's what I need, and build them together. And in those normal manufacturing businesses, what you would have is an engineering team. You'd have your own architect, you'd have your own crew of people. And at the scale of the cannabis industry, we've lacked that. And so what we have to do is we have to lean on the engineers and the teams that are out there that we can partner with. And for a lot of companies, the standardization has held us back. I've tried to ride the line in the middle for years, and having set up systems in almost every state and a couple other countries, I see the same version of events, on both ends. People customize and then they can't modify their process because their equipment was what was holding it together, kind of like the basement grower that can't go legit because he couldn't control a big environment. He started small. And I've seen people come from the standard equipment that can't figure out how to innovate new products because they don't know how to use something any other way. I think the perfect world is in the middle, and it's something that's accessible to anyone, but it comes from not just knowing how to do a thing, but understanding why what you did causes those results. And that's why I like the classes. It's one thing for you guys to build a big giant crystallization system. It's another for you to teach people how to crystallize their material. But it's a third thing entirely for people to truly grasp the concept of crystallization in a way that they can ask for the equipment they actually need to do the thing they actually want to do. Someone with Linden's mind, he's going to answer the question you ask him. And so you better give him the right question, because if you tell him you want to do a crazy, weird thing, he's not going to ask you why you think that's a good idea. He's going to figure out how to do it. And so for you to know the difference between what you actually want to do and what you're asking to do, I think is a huge benefit. I think it's kind of the difference between an expert in the understanding and in the theory versus an expert in equipment operation. To know how to extract is different than to know how to extract using what piece of equipment, one method and one SOP. And from a conceptual perspective, how to optimize is a whole other skill. And, that's kind of what I bring to the table as a consultant. Most of the time I'm going into businesses that are not just fully functioning, but that are fully functioning fast and expanding. And, so people need consultants early on when they know nothing and as they go to make sure that they aren't missing anything. So, what I love to see is people ready to learn. And what I love doing is helping kind of fit in the middle to know, like, sure, it's a nice idea when we say we want 1,000 pounds a day, but we never mean 1,000 pounds of one strain. We never mean, and so, we got to get exactly what we ask for. We got to ask the right questions. And I like living in that role because there's a lot of bottlenecks that we create for ourselves, either through doing things a weird way or asking for the wrong solutions up front. And having people who can, as you mentioned earlier, fabricate and test and then probably refabricate. You know what I mean? Like sometimes we can modify our SOP to get our results, but sometimes there's a physical solution that guarantees those results. And that's, those are the successes I live for.
Well, let's dive into some of those. I'll just say my name's Matthew Erickson. I'm one of the co-founders and senior technical sales manager at Evolve. I just wanted to touch on if there's anything in here that we cover. There's a bunch of stuff Linden's going to be going through. He's got the itinerary open here. But if there's anything that we don't have enough time to dive into specifically and you want more information on, you can reach out to me directly. We can also look at how it can be integrated into your existing system or your facility. You can do so by just adding into the questions your contact info, and I'll be sure to reach out to you. There's also going to be some correspondence after this. All the attendees are going to get an email. My contact info will be on there. Give me a call or email. Linden, take it away.
Sounds good. Yeah, the general way that I was thinking we would run through this is we'll start with some bottlenecks that are pretty easy to fix. And kind of as we go through, it'll get a little bit more into, the thermodynamics of the system and, heater and chiller selection and whatnot. But we'll start with, how long does some simple things like how long does it take you to switch over your columns? Where are some tedious procedures that we see really often? And then we'll spend some time on active recovery versus passive recovery. Really, I think that's a big one that the industry is a little bit, we could go forwards faster on that. And then I'll talk about stop-start systems, heater chiller sizing, and then if we get to it, we'll talk about the regenerator, which is a cool little trick. So let's just jump into it. So I think actually this is a little bit out of order, but the first one I wanted to talk to is almost every system, when we go into a facility, this is extremely common where people are constantly kind of disconnecting things and reconnecting and essentially, jangling systems as they're trying to process. And so this is kind of one that I thought would be the, low-hanging fruit and kind of one of the easiest to address is we've done some studies on, if it takes you an extra minute to run a column because you have to disconnect nitrogen and reconnect vacuum and then reconnect clean solvent when you swap it over on top of the, all of the messing around with tri-clamps that you already have to do to load and unload socks, you can add a significant amount of time to the extraction process, which really accumulates to a significant amount of throughput. And also you have significant wear on components like quick connects and whatnot, and it's not very conducive to training operators. So as you start to become, a director at your extraction facility where you're training new staff and whatnot, disconnecting hoses and reconnecting hoses and having these like complicated processes is really easy to solve. And the way that we solve it is we have these manifolds. Actually, Murphy gave us this idea of shrink wrapping and color coding them, because when we were initially doing the seminars, people were coming in and giving us the feedback that it felt like they had just walked into a spaceship. And it was kind of interesting. Like, I think there's this kind of curse where once you've run extraction for a while, it doesn't look like a spaceship anymore. You're following the flow paths and stuff like that. But when you bring the new person in, they're in the spaceship again, right? And so having it so that they can make really easy decisions and minimizing mistakes, like, accidentally sending your micella back through your nitrogen line or something like that is like avoidable if everything isn't just silver. And so I just wanted to touch on that I think that is, like, I put it down here, like if you like saving a minute per column, if you're running a column every 10 minutes, saving a minute per column is like an extra 4 or 5 columns a day. It makes a huge difference. And then there's all the mistakes and stuff like that.
And don't skip over that color coding is doing double duty as insulation. And so you're going to save time by insulating those lines, preventing all the frost and buildup that then turns into slippery water that mixes with weird weed particles, and you end up having to clean later. Like, the efficiency of that system works all the way downstream in your prep and your cleanliness. And, if you can, anytime that you can double time there, we've got color coding and efficiency and waterproofing, all in one. It's a shortcut, and it costs time, basically,
Yeah, just good labeling and stuff like that. I mean, we see this in the manufacturing space. We see this here, just like everything what is it? A place for everything in its place. And it goes extremely well with piping as well, too. Then the first bottleneck, another one that is relatively easy to solve and relatively inexpensive is we encounter this a lot where if you're ever in a position where you are waiting for the column to be switched over. So we found that, to undo a 6-inch tri-clamp, to pull the sock out, to replace the sock, put it back on, and then vacuum it down, it takes about, most people 5 to 10 minutes, depending on their skill set, how careful they're being, what tools they've got, and whatnot. And if you are waiting for that, then you need to buy more material columns. This is another really easy problem to fix, where if you're kind of waiting for, or if you don't have the time to do that, you just need more columns, right? So we always suggest, like, we walk in and we see like systems with 2 columns and stuff like that, really easy fix. is to just purchase more columns so that you can be unloading one while you're loading another, while you are running another kind of thing. And so we always suggest a minimum of 3 so that you have ample time to be transitioning between while one is running. And it just puts you down this path as well too, where your focus should be solvent recovery, and other parts of the processes should not be going as quickly as you can aggressively to try and solve this problem. You have anything on that, Murri?
Um, I would also add that multiple columns also gives you a much faster changeover at the end of a batch, because you can always have sections of the system that are quote dirty and that are quote clean with filtration in between them. So from a toll processing perspective, you can set up parts of your system where, let's say when you're running like dry powdery weed, you're using different filters at the bottom of those columns, and those could just always be set up in that area versus other columns where you're using less fine of filtration because you're batching it to do, mass CRC later. And so you can, kind of use those physical locations as a way to support your staff, much like proper labeling and color coding. If this column always takes this type of filter, they're never going to accidentally put the wrong type of filter on it. You can geographically allocate space to specific processes, which is then going to make it a little bit easier for everyone to kind of know what they're supposed to do. When you start encountering scale, one of the first things that I find as a consultant that people have to overcome is the extra bodies in the room. And so, from the perspective of adding more columns versus adding more people, one person can keep 3 columns running. Whereas, to have one column fast enough, there's often a second person who's getting handed stuff, and you have 2 people handling the equipment, 2 people touching wrenches. The number of times I have heard, "Where is the flashlight?" Wasting your life. And so when you can double up on these columns and double up on some redundancy, for example, if you have 2 collection vessels and one's for your in-house material and one's for your external material, then your ability to switch from toll to in-house, can be physically oriented so that you're not cross-contaminating batches because they're kind of predestined based on the equipment you put in place. And this is something that, without the physical restriction of the booth, would come much more naturally. We see that, in kitchens, for example, where like it's just a different pot for a different type of candy, and you never accidentally make a different candy in a different pot because they're just assigned. With the demand on an operator, you've got all of these different products and all of these different, SOPs associated with how they're going to run different material for different people, for different things. Anytime you can create some redundancy to support them, you're going to make it easier for them to not make a mistake. If you're relying on one column on a changeover, the likelihood that you're going to unseat a column gasket, the likelihood that you're going to have a dirty filter that gets clogged, the likelihood that something could go wrong, you can lock that up really tight with just a little bit of equipment. And again, the cost between an extra person in the room supporting them versus that one person having 2 columns to pick from, the columns are cheaper.
Yeah, so actually super quick, back to the columns, really something that I preach is essentially this concept of the entire hydrocarbon process, in my opinion, is continuous except for the columns. They're currently, unfortunately, inherently just a batch process. And so a good metric is to kind of time it out and see if you can not ever stop your solvent recovery, then you're in a really good place. And then you can start looking at, the next part of the webinar that we're going to talk about, which is all to do with solvent recovery being the bottleneck. Because if solvent recovery is your bottleneck, you're in a really good place, provided it is fast enough. So one thing I wanted to talk about here was the difference between active recovery and passive recovery, which has been a discussion in the industry for a long while, but I think is very important to understand why more and more people are going away from active recovery and towards passive recovery. And it's simply because it's faster and it uses less energy. Recovery pumps are convenient in the sense that you can turn it on and you can see kind of what's going to happen. they have that convenience item, but I really don't believe that it's worth the decrease in production throughput. So recovery pumps are, they're slower to recover than passive systems that are designed properly. They require additional cooling, and also your system operates at a higher pressure. And to dive into the weeds a little bit here, what's going on is that a recovery pump is, it's essentially adding a lot of heat to the system, which you then have to reject. So the way that a recovery pump works is it's pulling gas out of the collection pot and compressing it, and then sending it into your solvent recovery. But throughout that process, you're adding an enormous amount of energy to the system that you then have to pull out with a chiller. And then, as you condense, then you again have to cool that solvent down. And so you're kind of fighting yourself in that regard, because you are already adding heat at this collection pot and you're already adding cold over here. The compressor pump is kind of making that a lot more difficult to do. And it's also it's very difficult to scale up when you have a recovery pump, in the sense that all you can do is just buy another recovery pump and then you have two instead of one. You can't really scale it up very easily or very cost effectively. And so what we suggest instead is a passive system. And the difference being is that you essentially pull out the recovery pump, you pull out the chiller that was in charge of removing all the heat the recovery pump was putting in, and all of a sudden you have, we've seen up to, with the same heat exchangers, the same collection pots, we've seen almost 10x the increase in throughput by actually removing, 60 grand worth of equipment out of the equation, and your solution also comes back into your solvent recovery tank a lot faster. So the way that it works is you heat up your butane and propane blend and boil it off, and then you passively condense it. So you use only the fact that the plate exchanger is cold enough to condense your solvent, and it will naturally condense and then pass back into your solvent tank already at your extraction temperature. And so it's faster, it requires less energy, and it's also more conducive to a continuous system.
I'm just curious, people that are watching, love to know which of you guys are already running active or passive. If you wanted to just put into the questions, be cool to see kind of a breakdown.
Yeah, passive, active, passive, baby. Nice. Yeah, once you get passive recovery, active. Once you go passive, I don't think you go back. I mean, we do active recovery for things like separating propane and butane or something like that, or like if we're pulling a collection pot down to vacuum, we'll maybe use a collection pot. There's like some convenience, but to me, a pump is a convenience item. It's like you can say, okay, I know what's going to happen, and I can pull this pressure down, even though I don't have the temperatures to support it. But for bulk recovery, it's not really the right tool for the job.
Yeah, I think it's all about having a tool for the task, Like I love a recovery pump for the last 20 pounds of a butane refill tank. It's not coming out otherwise, right? And so, to be able to suck it all out of a tank and into the system is valuable, but I don't want to rely on that same speed of recovery for 100% of my gas recovery methods. A pump will never be as fast as the fastest passive with the same cooling, because the pump is always going to be limited to that 4-to-1 output. So,
Yeah.
It's good for those like low pressure recovery moments where you don't have a good way. Like, raise your hand if you've ever put a refill tank into a trash can full of hot water to get it to come out. It's like we've all, had to make choices to kind of overcome it. And I think a pump has a place for gas movement just outside of your extraction, and not necessarily as a part of your regular SOP. If you've got the correct heating and cooling,
Yeah,
you will always be faster passive.
Yeah, the limitation on passive is how big of a heat exchanger have you got, and how much, capacity, what size is your chiller, how much can you pull apart. So like, I remember, up in Canada specifically, large heat exchangers that were cooled from and like, there's no limit to how fast you could recover. It's just depending on heat exchanger size. I mean, they're relatively cheap.
Question of surface area then.
Yeah, exactly. But like, these plate exchangers, like we use the same heat exchangers on our ethanol and heptane evaporators as we do on here, and they can reject 60 kilowatts of heat. Nobody here, I don't think, has a 60 kilowatt chiller. So it's very easy to just reach that maximum. And so it really comes down to chiller selection, which we'll get to in a second. With that, though, I wanted to address, so, when people start running passive, they encounter essentially flow issues. And it stems from, it's kind of complicated sometimes to wrap your head around the head pressure within a system and how to get this thing to move. And with that, there's this concept of stop-start systems, as I call them. And I'll run through what that is and then how we've addressed it. So this is a system, you can imagine they had a recovery pump and they just switched to passive. The recovery pump used to sit here. What they do to get the solvent out of the solvent tank and pass it through the columns and into your collection pod is they add a nitrogen head pressure to the solvent tank. And that works pretty well. It gets it moving, but the challenge is that, so if you've added, 40 psi of nitrogen head pressure to your solvent tank in order to get that liquid solvent to drain out, go all the way through your column and then into your collection pot, you have 40 psi in here, which means that you can't be recovering solvent until you off-gas that nitrogen. And what that effectively means is that, okay, sweet, you have a really high solvent recovery rate when you bleed off that nitrogen and you start your recovery, but that is a bit of a lie in the sense that you're only recovering for 50% of the day, because half the time you're running extractions and so you're not recovering solvent. So you have to stop the system and then start it. And then so people buy second solvent tanks, and pretty much you end up running two different systems. And so what we do instead is we use a liquid pump, which is really cool, because what we do is we keep the pressure in the solvent tank really low, and we're pumping liquid out continuously and cooling it on the way through, and then pumping it into our collection vessel, which is actually at higher pressure than our solvent tank. And then the passive recovery, the gas travels extremely quickly back through the plate exchanger, condensing on the way so that it doesn't increase the head pressure in that solvent tank again. And the loop is truly continuous, because as you're pumping this liquid solvent out, you're decreasing the pressure in your solvent tank and you're increasing the pressure in the collection pot. And then it rips back as a gas, condenses back as a liquid, and it goes in a loop over and over again until, as long as you can keep on packing columns and you have a way of topping up butane as you lose a little bit, this is just, it's a continuous, true closed loop system. We're a strong proponent of those. And then also with the liquid pump, you can pump it in a loop and cool your solvent really quickly. So if you are having a situation where you're waiting for your solvent to cool down, which is another common bottleneck, that definitely slows you down. And so you can kind of pump it in a loop, or you can just pump it through a plate exchanger on the way to your extraction, and that'll kind of speed you up a lot there too. Murphy, do you have anything on stop-start systems, or maybe I'll go on to heater and chiller sizing?
I mean, I think the only thing I would add is that really, there's kind of a time and place for everything. So I love a continuous flow for extraction. And what I'll usually do is batch the extraction into a big holding tank. And then I do a stop-start for my filtration, because I like to take a lot of fractions and I use more of a chromatography method for my filtration. So from a systems perspective, I like to have the components that support both methods to do different things. And if I, let's say, only had 2 columns worth of material, tiny batch, maybe it would make sense to do everything in line. But then when I have 200 columns worth of material, I'm going to batch it into reasonable chunks based on those pieces. And so, sometimes your scale calls for a start stop. I think about if you were toll processing, you'd want the ability to do a quick in and out for a test run, for example, to just see what that material looks like and make an assessment of, what's going to come next and how you might run it later. So, having diversity in your capability, but then, a flow line and a layout and the tools on hand that allow you to optimize within that, ton of value there. To stop and start is how most people began. And, the way that they solved it, as you mentioned, like you can buy an additional solvent tank. You can buy a bigger solvent tank. You can buy more columns. What you can't do is make all of those decisions without thinking through where the next bottleneck comes from. And so if you bought something and created a bottleneck you weren't expecting, that would be the negative. if you can plan for where that bottleneck is. One thing someone asked was, how fast I'm going fast enough. As long as you run out of weed before you run out of gas to fill another column, it's fast enough. And so if you don't have a lot of weed, it's okay to have a smaller version that starts and stops as long as the rest of your system is sized accordingly. What you want to know is where you're going. At a certain level of scale, some of this makes sense to start and stop. At a certain level of staffing, sometimes you got to start and stop. If you've got the team to get in there and run continuously, you should have the fastest extraction possible and not run two shifts, cut down that labor. Everybody's business is going to be a little bit differently. And so thinking about your needs alongside of these like options, it's not really one is better or worse. It's some are better or worse for specific scenarios and specific applications, thinking about how you want to use it and how your workflow really needs to be. Some of you guys are going to be owner operators, and so you're going to interrupt the run to go take a phone call. And some of you have staff and you're going to make them leave their cell phone 150 feet away up front in their locker, and they're not taking phone calls. And, those two people need different flexibility in their system probably.
Yeah, absolutely. I'm definitely taking this, the approach that everybody's trying to industrialize, which is maybe a little bit more my mindset in some cases. But yeah, start-stop systems is how everybody learned, and they have a place. But as you scale up, it's got to be like a factory mode.
Yeah, and you've got to scale up your staff to match.
Yeah.
You got to change the way you work.
So with that, a few people in the questions have been addressing this as well too. Is you're limited by your chiller, but you're also limited. I kind of breezed past this a little bit, but you are also limited by your heating capacity. The reason I breezed past it a little bit is because hot water is a very achievable problem to solve. Like we use these on-demand hot water heaters a lot, which I'll get to in a second, but you can very easily, especially if you have natural gas on site, have more hot water than you'll ever need and circulate it really quickly and not have to. So if you're dealing with like this tiny little like recirculating heaters and stuff like that, and your heating is your bottleneck, like if you feel the outside of your collection pot and it's cold ever, then great news. You can fix that problem really easily, and you can probably double your throughput just on with a little bit of extra heat. But yeah, let's talk a little bit about heater and chiller sizing, because we get into a lot of conversations where temperature is conflicted with kilowatts. That's a really common one where it's like, oh, my chiller's super cold, I should be going super fast. Well, unfortunately, no. It's how much heat it can reject, not how cold it can go, which matters. And then same thing with the heaters as well too, to a lesser degree. But I just wanted to go through some charts. Solvent recovery the speed, the size of your heater and chiller is directly correlated to how fast you can recover solvent, which is directly recovered to or associated with how much solvent you can recover, how much biomass you can run and whatnot. But I thought that this was an interesting way of looking at it, which is where if you have, between 5 kilowatts of heating or cooling versus, 20 kilowatts, it's, there's your 3x or more immediately, right? Just on having the right size heating and cooling. And so identifying that and kind of getting an idea of how fast your solvent recovery going and why is it stalled? Is it because you can't reject the heat, or is it because you can't heat up your collection pot enough, is very important to identify. And then at a 3-to-1 rinse ratio, 5 kilowatts of heating and cooling versus 20 kilowatts is the difference between running at like 25 pounds in a day versus running like 125 pounds a day. It has a huge impact. And so, yes, chillers are expensive, but you can calculate it out, and it's almost always worth it. And this is why too we try to, when we're suggesting chillers to people too, we always try and future-proof it. Like if somebody's, maybe we're going to make these upgrades in a few years, it's often cost-effective to buy a larger chiller up front. And if you look at it in regards to THCA produced, you'll notice these are all just the same graphs. I just calculated kind of what they were all equal to. But if you can produce an extra like 5 kilos a day of THCA, how many kilos of THCA is in a chiller? And then this is kind of just to give the people an idea of what is a kilowatt. I thought this would maybe help jog people a little bit. Is Actually, to flip ahead one slide, a lot of people have these little circulators, and I think, Huber makes really good equipment and stuff like that. I'm not trying to knock them, but it's kind of just the right tool, the right job. They're underpowered, right? And if you're heating your collection pot with something that's 2 kilowatts, you have the same you have less than a stovetop burner, in charge of your industrial process. And so if you can go towards something like a on-demand hot water heater, which is, one Home Depot trip away, you can significantly increase your throughput. Mind you, you do need more than just the system. You need a circulation system and some filters and stuff like that to get it all working, but relatively low-hanging fruit. And then just to give a look at these chillers too, another thing we encounter a lot is like, hey, can I use this chest freezer to cool my solvent or something? And the answer is you shouldn't do that, because first of all, it's not Haslock. Second of all, like the chilling capacity of these industrial chillers makes a world of a difference, and they're not significantly more expensive than some of these like mid-range chillers that are really geared towards like chemistry experimentation. In my opinion, they have really tight tolerances to their output temperatures. There's all sorts of like automations that you can do, and like integrating with like other equipment. But we don't really need that here. That's not really the goal. The goal, in my opinion, is to get as much heat condense as much solvent as you possibly can, in which case we suggest going with a more industrial solution. Yeah, we're making pretty good time here. We're already on the Regenerator, so we'll definitely have some time to answer some questions here. I think Sean is asking what pump we use. Yeah, we use liquid, a custom-built liquid diaphragm pump. We can address that. What data is this chart based on? Yeah, so those charts that I was going through. Yeah, so just to walk through how I came to those numbers, just before we go back to the Regenerator. Just to go through these charts. So what I'm talking about here is kilowatts versus solvent recovered is just, we use a number called your enthalpy of vaporization. There's just a very defined number for how much energy it takes to boil off a certain amount of butane. And then this chart, how much biomass you're extracting, that's the way that's calculated is assuming a 3-to-1 rinse ratio. We use a 3-to-1 or a 5-to-1 rinse ratio. And then how much THCA that produced was with like a 10% yielding biomass. I just kept super standard numbers, but just to give you an idea of the impact of properly sizing your heating and cooling. Suggestions of diaphragm pumps. When you run a pump factor, use 2. Okay. So with that, I wanted to talk about regenerators, because they're one of my favorite pieces of equipment, because they essentially, you operate them for free. So there's this, I guess the best way to explain it is it's a heat exchanger that recovers your cold. The cold from your processes, and it uses it to condense your solvent that you're trying to recover. So your extraction, you're typically cooling your solvent down to -40, and you're sending it through these columns. And by the time it comes out the columns, it's still at -40. And you're sending it into your hot collection pot, which then has to heat it back up and then boil it. And so what we do with the Regenerator is we cool a heat exchanger down, which condenses the butane that we're boiling off. And it's crazy, because you can get an additional, like, I think with butane, it's an additional like 36% recovery. So another third or more of what you're already recovering, you can get for free by putting a heat exchanger in the right place. And what you're doing is, again, you are using the cold butane from extraction to cool your heat exchanger down, and then you're condensing the gas on the outside of that heat exchanger. And so it helps your heater has to do less work, your chiller has to do less work, and you get a whole extra third of your production for free by just putting that heat exchanger in the right place. And so that's often the first thing we do at people's facilities is we just toss a heat exchanger in, and all of a sudden there's this effect too where your collection pot's at a nice rolling boil, and then you shoot in cold butane and it goes completely flat. And so Yeah, and that no longer happens because at the same time as you're condensing that butane, you're actually preheating your cold butane from your extraction. So your butane solution with your resin in it is now at the point where it's right ready to boil by the time it enters that collection pond. So you get a huge speed boost both on the evaporation side and on the condensation side, which is kind of a bunch of fun. I'm just reading some answers. Oh wow, people are answering this as we go. We run the Unistat 3.5.
I'm trying to answer everybody who's popping up with specific stuff as you're chatting.
Yeah, so let's start just answering these questions as they come in because we got the time.
Yeah.
How do we run the Unistat 3.5 kilowatt chiller? How can we determine whether or not to upgrade or know the fact that our chiller is sufficient? Well, the main thing is, are you building head pressure in your solvent tank, right? Are you noticing that whatever your condenser looks like, are you getting gas run by? If you are completely condensing, what should happen is you never see your pressure rise in your solvent tank at all. Your liquid butane comes in cold, ready to go to your next extraction, and your pressure head, if anything, decreases because you're cooling your tank from that effect. That's how you know it's working well. And if it's a 3.5 kilowatt chiller, unless you have like exergy coils or something like that, you're probably not using all of it.
I would check it too. Like one thing, a lot of people mention their Hubers, and they have a great, user display for this, but uh, make sure that your chiller is maintaining the set point under load. If you're in the middle of the peak of recovery with the frothy, foamy, excellent fast, recovery rate going on, if that chiller is not able to hold temp, then you could potentially improve the efficiency by insulating your lines better. Anywhere that you see frost, you are losing that cooling energy to the room. And so increasing all of that insulation and seeing if your chiller can hold a set point is going to be really key because, as you mentioned, adding a heat exchanger in the right place is important. While you might need a bigger chiller for the giant tank you bought, the small chillers you have might be perfect for a heat exchanger. And so, the amount of surface area that you're exposing them to goes a long way. 3.5 kilowatts, but with a pump that can only replace, 50 liters compared to something that's got a pump that can pump 50 liters, a minute is going to be a big difference. And so the sizing, is going to impact how far it has to travel. And, you're going to lose energy on things like distance and vessel size and even vessel shape, frankly. A distillation in a big wide vessel is differently efficient than a big tall one. And so you've got a lot of factors that you can influence. And a lot of times the way that chillers are used is out of spec. If you're setting it to the lowest point it's capable of, you've got the least available energy output because it's doing everything it can to keep its reservoir cold instead of actually, investing that, cooling capacity in that, process. And so I like a chiller that can run at like medium to near lowest and not have to run at the lowest and hold that line. Sometimes the chillers that we've selected for, I see a lot of people who are just running kind of chaotically random chillers because this has the lowest, saying negative 80 doesn't mean negative 80 and saying tons of kilowatts doesn't mean cold. We've got these big MTAs out there that are running at like 10C and, it's got a pump that can make moves and it can replace that fluid quickly, but it's never going to get cold enough. But then you have a Huber that can get to negative 80 and it can't replace the fluid on a material column, fast enough. And so, there's a specific kind of realm you've got to live within. If you've got an existing chiller, there's always a place we can apply it and make it work, but it may not be every column in the room. It may not be every tank in the room, and it may not be at the lowest set point that's available. Sometimes you got to use what you've got, and figuring out where it's most appropriate goes a long way. Same with your heaters. A small heater on a location that is not always under load is fine, but losing kilowatts in a place that is taking direct heat load constantly, you want to have that action. You want to have that energy directed there.
Yeah, a few people are asking about, temperature fluctuations and limitations with the hot water systems. And the real secret there is like to have good flow rate. Like if you have yeah, you want to have like 10 GPM, 5 to 10 GPM, and you'll have much more consistent heating. If you're seeing like spikes where you're cooling, it's not necessarily that your heater can't keep up, it's that you're flowing liquid just a trickle through there, and so it gets into the jacket, it cools down, and then it's not doing anything.
Hmm.
You can have a super high kilowatt heater that doesn't do anything if you're not circulating fluid through it, so we can definitely help, size that out properly and stuff like that. You need that enough fuel.
I'd say if you're running a hot water recirculator too, if you haven't drained and replaced that water in the last year, it's time. The buildup inside the fittings and hoses is foul, and that will limit your flow rate insanely. And the more valves you put on your system, make sure they're full bore. Any valves on your fluid flow line can extremely limit the flow rate. If you're going from, like, let's say a 5/8 line down to this 1/4 inch valve and then back into the vessel, you're giving yourself bubbles and bottlenecks that are no good. Sometimes, just simple changes to that application can go a long way.
Yeah. I just saw an interesting one here, which we didn't touch on during active recovery, but Thomas is asking why you think 70/30 over straight butane is beneficial for throughput. And that's super interesting. So propane came in partially early on. We know now, I think, that propane is used to pull more terpenes and produce a nicer extract. But initially, I think a lot of people were using propane because it created a higher vapor pressure at the inlet of your pump, and so you could pump it out of your collection pot faster. Where butane is a little bit sluggish. Doesn't really matter with passive recovery, in my opinion. You just increase your temperature, but that is why there was it was beneficial for recovery, as it works better with a pump.
Here's a fun fact. Any canned gas is basically 70/30.
Yeah, because
If you were
butane,
ever
you're
blasting with a
lighter.
can, yeah, so the propane was the propellant. And so the way a lot of people use 70/30, propane is a propellant in the solution. The butane's extracting and the propane is pushing. And unless you are pressurizing that column, the propane's not getting condensed. So it's just kind of doing the job nitrogen would, but can be condensed by your pump and can be recovered as a liquid, whereas nitrogen isn't being compressed by the pumps we're using for butane. And so in that regard, you have to off gas it and waste it. And so, you can use, kind of back to your regenerator idea, use high pressure where you need it, and to use it with a gas that's compatible with your product that isn't going to impact your yield negatively, it is super valuable. You're keeping it in the same family, and not having to add an external variable, an external flow line, and an opportunity for things to change or go wrong. And I also agree, soaking for a long time is equalizing the head pressure inside the column. And so things that were dense as they were flowing in become less dense. And I don't like chilling my columns personally because you can drain them faster when they're warm. The high-low differential, you want to give yourself all the support you can to get it into your collection vessel, especially if you've got a big wide one from certain manufacturers, and those are hard to fill. But the reason open blasting worked is because we had a propellant and continuous flow and an evenly packed column. And so if you keep that in mind, you had unlimited solvent recovery, unencumbered solvent recovery in an open blast. Of course, it wasn't recovered, but it was unlimited in the flow through. And that's when we got our best yields and our best product. And it's because we were not limited by solvent recovery. It was continuous there and uninhibited. And everything else was based on a nice tight pack, even flow. If you got real fancy, you use your hot water dish, but those same concepts that were true then are true now. We've just hidden them behind stainless and we don't see it always.
I'm running
Looks like we
dry
only have
ice.
1 minute.
Dry ice rips, but it just costs a lot. Dry ice is infinite kilowatts. Just how fast can you shell it? Yeah. What should we do for the last minute? Do we want to say some closing parting words or something? I don't know.
Something.
I will say I did finally get to run a system with a liquid nitrogen on demand for cooling. And I always said it seems too expensive to be worth it. We turned it on 5 minutes before we ran and it was ready. I love my big GD chiller, but oh boy, if you can afford it, I've changed my mind.
Can you freeze butane with liquid nitrogen though?
Potentially, but you regulate that. It's highly regulated. The control panel in the outside the room is like you set those parameters in advance. So the fact that it's frozen out there, you are tightly controlling it before it ever enters the booth. I questioned it, but it was actually great.
Okay, well, thanks everybody for joining in. If we didn't get to your question, we'll be scouring through and reaching out. I know that I've messaged a few people saying that I'm going to get back to you with some more information. But just as a reminder, there will be a follow-up email to all the attendees. It's got contact info. It should also have some info on our next webinar on the crystallization temperatures. I'm not sure the exact title, but all the info will be in that email. If you have any questions or follow-up, or you want to have a more in-depth discussion, see how we can integrate stuff into your lab, reach out to me. I'll be happy to help you. And thanks so much for joining, and hope to see you at our next webinar. Thanks, guys.
See you guys.
Thank you.